Hello guys, welcome back to my YouTube channel. Today I'm going to demonstrate how we can build a post human estimation tracking that can show whether a person is actually exercising or someone is just not doing any exercise. In this case, I'm going to use MediaPipe pre-trained model, post estimation model that detects the body landmarks. Just to show you a quick demo of this project, let me just run this project. So as you can see over here, we have different, a human body has several parts, and as you can see here, they have all been annotated. You can compare it with this image here. Let me show you side by side so that you can see. You can see that the eyes, the face has already been annotated. The point 9 and 10, as you can see over here, represent the mouth. The point 0 represent the nose. It has already been indicated here. And these points, these represent the shoulder. That is 11 and 12. The other one is 12. You can see it clearly. Number 24 and 23 represent the hip. Yeah. And then these are the knees that have already been indicated here. So in this program, I wanted to show you that you can build this project using MediaPipe. You can also use YOLO, the version that you want, YOLO V8, V26, depending on whatever model that you want to use. So I'm going now to stop this project here so that I can explain the code aspect of it. So let's get back to our project here. So MediaPipe is, as I told you, is a pre-trained post estimation model that detects the body landmarks. And the body landmarks I've already provided it over here. You can always get them from Google, their website over there. We have some key values that are coded. That is the maximum confidence we use. That is the minimum confidence. The threshold for detecting and tracking a pose. In this case, 0.65 represents 65%. The maximum number of poses for us to know whether a person is exercising or not. We have 4. So if we detect like 4 parts are in position, then we can assume that this person is exercising. So the number of frames, this represents how fast we can view the video that you're seeing over here. So as I told you, the post connection values you're seeing over here, like from 0 to 10, this from 0 to 10 represent the face of the person, and then 9 and 10 represent the mouth. The mouth is part of the face. And then the left arm are represented from digit 11 to 15 here. You can see over here, 11 to 15 here. The right arm is going to be presented by the opposite, that is 12 to 16. Yeah. So the body parts, the left leg, the right arm, the values are already represented here. The shoulders plus the hips, shoulder plus the hips are represented by these values here. So if you come and look at the shoulder to number 24, yeah, here, this is the hip. So I'm now going to show you how we can detect the pose. We first of all need to draw these landmarks on a human body before we go ahead and detect them over a video. So what are the key parts? So the first part we have to do is to draw detected pose landmarks and skeleton connection onto the image. That's the first part. So for every person that detected in the frame. So you have to remember these frames are just images that are being detected after a given period of seconds. So in this case, we have to remember that we have how many frames per second? We have like 30 frames. They're just being detected. So assume that the frames are just images in this situation. So we have to detect them and then connect these points, and then that's when we draw these landmarks that are already indicated in this pre-trained model here. So that's the first. That's the purpose of this function here. Draw landmarks on the images. So after that point, we use some of the libraries in MediaPipe, and we have over here, we just do the initialization aspect of it here. As you can see, we are using the confidence score, the minimum and maximum confidence score, Here we run the model on a video, and then here we indicate the model path. You can see over here, and then on what mode. So video mode represents the manner in which these frames need to be processed. They need to be processed in a video sequentially. So that is the most essential part of this part. And then the next phase involves now creating using opencv to display this video over here. So the timer represents and calculates the number of frames that we need to display per second. And remember, when you're displaying these videos, you need to know how to can handle the garbage collection, because after a given period, if you're live streaming, this is something you have to know, that sometimes you need to be able to make sure that the video that you're displaying doesn't consume a lot of resources in the computer to an extent that you can't really you can't really live stream for a very long period of time. So that's something you need to take care of. So opencv, first of all, as you can see over here, represent. So the frames are in BGR model, that's the blue-green model. They need to be converted back to RGB model. So it's just the reverse of what we have over here. And then after changing the colors, we need to be able to display this. We need to put the frames inside the landmark, the function landmark here. As I told you, frames, just assume that they are images, and then they will be drawn, and then they will be displayed. So the logic here, we have an heuristic that, as I told you initially, if a person has 5 or 5 or more parts of upper body, key points visible, we can consider this person to be exercising. That is the heuristic that I'm using over here. So you can always know whether this person is either squatting, is either doing push-ups or not. So you can extend it to do that. So in this case, I'm just showing that the person is exercising or not. So you can see over here, it detects the number of people in the images. So that is what it does over here. And then we annotate it and then display to the user over here. That's what you could see on the images. As I told you, when a person, every video, when you press let's say letter Q, that means you need to quit over the video, and then release the memory that you stored while trying to train the model, trying to use the model over here. Remember, the key thing about opencv is that you need to learn how to manage the garbage collection system. So thank you for doing this program, and watch out for the next video. Thank you.